All right, hello everyone, welcome back. So we got a short lesson for you today. Sorry it took me a while to post it. You might notice there's no webcam today because I'm not on my 10-year-old laptop anymore. We just built a computer yesterday and I'm pretty excited, so this should be pretty smooth. Still learning some of the new tricks, but I think you're going to enjoy it. All right, so yesterday we talked about central angles and lots of vocab with circles. So if you are still confused on any of that stuff, you might go back and watch that video again. But a central angle is an angle that's located in the center. So the vertex of the angle is in the center of the circle. So this circle here, if we go from B to the center to C, this angle here is 40 degrees. Well, if we want to look at the measurement of the arc, we measure the arc by their central angles. So the measurement of arc BC, so this is arc BC, the measurement of arc BC is going to be the same as its central angle. So arc BC is going to be this part here, like a segment. It's a set of all equidistant points from the center with endpoints strictly between B and C. So it's like a segment, but instead of being a part of a line, it's part of a circle, which is kind of cool. So this is the measurement of arc BC, and it's going to be the exact same as its central angle. So if the central angle is 40 degrees, then we know the measurement of arc BC is also 40 degrees. If we want to find the measurement of arc AB, going from A, the shortest distance from A to B is going to be this part here. That's going to be the minor arc. So the minor arc AB here, the measurement of that, well, we're going to be able to figure that out by looking at its central angle. Well, if you look at AC, this is a diameter. It's a special chord that goes through the center point, right? So that means that this is going to cut the circle into two semicircles, which have measurements of 180 degrees. Also, we know that this is a straight angle. So if this is 40 degrees, it means this angle here has to be 140 degrees because they add up to 180. So if the central angle is 140, that tells us that the measurement of the arc is also going to be 140 degrees. Next arc we want to measure is arc ADC. So going from A, the shortest distance to D. So A to D is down here. So we're talking about ADC. That's going to be our semicircle. And again, the reason why we had to define the semicircle, we can't just call this arc AC, is we don't know if we're talking about AC going from the top or AC going along the bottom. So to define a semicircle or a major arc, we have to have at least 3 points. So this is arc ADC. Well, if the other side's a semicircle, so is this one. It's got endpoints, chord with an endpoints through, so it's a chord that goes through the center, so that's a diameter as well. So this is also going to be 180 degrees. So the measurement of the arc is going to be, is going to be 180 degrees as well. So ADC is 180. Then we have arc BAC. So I'm going to move these out of the way real quick. I'm just moving back here so we're not confused by them. But BAC is going to start at point B, and the first place it's going to go is the shortest distance from B to A. So we're going to go counterclockwise, so B to A, and then ends up finally at C. So if you notice, that's going to be pretty much the entire circle. The only part that's missing is going to be the arc BC. So there's different ways that we can find the measurement of this arc. We could first add the measurement of arc BA or AB, which is 140, and then add the other semicircle, which is 180. So let me pull up my calculator here. So we could do 140 plus 180, which would give us 320 degrees. Or the way that I like to do this, because it's basically the entire circle, the only part it's missing is the 40, is we can do 360 degrees minus 40. So we'll do 360 minus 40, which of course leaves us with 320. So multiple ways that we can do that, just showing that to you because it's kind of cool. So let me move the calculator out of the way. So that would be 320 degrees. All right, so the only thing new really for today is inscribed angles. So inscribed angles are angles where their vertex is no longer in the center of the circle, but now their vertex is on the circle itself. So this angle here is an inscribed angle because it has the endpoints are going to be on the circle, of course, but the vertex is on the circle as well. So it's an angle formed where all 3 points of the angle are going to be on the circle. Well, if we knew that the measurement of arc AB was 50 degrees, then we know the central angle is also 50 degrees. And if you just look at this angle here, does it look like it's also 50 degrees? So look at the size of this angle and the size of this one. Is this angle bigger or smaller than 50 degrees? So you're probably screaming at the computer screen or your phone, and I, of course, can hear you, which is so cool. And you're saying it's smaller. Of course it's smaller. So then the next question I'll ask is how much smaller? If you just had to guess, and I haven't taught you what it is, there is a formula, but how much smaller does it look like? And we think about if we go from this distance here to here, and then I double that distance by adding another radius here for the diameter, if I go twice as far back, what do you think happens to this angle? All right, if you guess that it's half, you were exactly right. So the measurement of this angle here, the measurement of angle X, is actually going to be 25 degrees. So see how my handwriting is today. But it is 25 degrees. So it's going to be half the measurement of the arc, which is also half the measurement of the central angle, which is pretty cool. So inscribed angles have measures that are half of their central angle. All right, so central angles versus inscribed angles, kind of putting this all together. So on this one, notice that the shape we have here is an equilateral triangle. So all three triangles are, all three sides of the triangle are congruent. So it's equilateral and equal angular. This is also an inscribed triangle because its three vertices are going to be on the circle itself. So which gives us three inscribed angles. So this is a unique diagram that I think is pretty helpful in thinking through this. Well, if I asked you what the measurement of these angles are of an equilateral triangle, you know they're already 60, right? So next thing I'm going to do is kind of show you this helpful piece here. So if I connect the center of the circle with the vertices, creating these three radiuses, we know those radiuses are congruent as well, right? Well, what did I do to the whole circle? So the whole circle just got cut in three pieces, just like the circle kind of in the middle did as well. So let me see what this is. No, I'm going to show that to you in a bit. All right, so let's go ahead and mark up our diagram real quick a little bit. So we know that this angle here is going to be 120 degrees. So this is also going to be 120 degrees. Now I think I'm going to show this to you. Let me switch quickly. Yeah. All right, still working on this. So the question I have now is, what is this inscribed angle here going to be? Well, as a part of the equilateral triangle, we know it's 60 degrees. But also, if we took this 360 in the middle and we split it up into three pieces, so we have 120, and then we would have 120 here, and we would have 120 over here as well. The same thing happens with the measurement of the arc. So this arc is measured 120. This arc over here is also 120. And this one on the bottom is 120 as well. So what's the measurement of the inscribed angle? Well, remember the inscribed angle, which is an angle that has the vertex is going to be on the circle itself, is going to be half of the central angle, or you can say it's half of the measurement of the opposite arc. So if this is 120 degrees, this one would have to be 60 degrees. And you could do the same thing for this angle up here, right? That would also be 60 degrees. And here you also have 60 degrees. So yeah, kind of cool. Central angles versus inscribed angles. So the central angles are all going to add up to 360. The inscribed angles just depend on the shape. So in this case, an inscribed triangle, they have to add up to 180 degrees. And when we divide that by 3, we get 60, which 180 is half of 360. So kind of cool stuff. We've looked at a little bit of that before. Let me show you another version of this diagram. So it's all color coded out, which is fun. Makes it easy to read. So we got 120 degrees for each one of these arcs. So 120, 120, 120. The central angles are color coded 120, 120, 120, just like their angles there. And then on this side, we've got one of our inscribed angles. And we said this blue arc here is going to be half of 120. So that is going to be 60 degrees. So this central angle, inscribed angle is 60 degrees. Now what happens if I take this line here and I move it out to here? And notice my point referencing there, that's to make it look good in the end. So what happened to these angles now? So we knew that blue section here was going to be 60 degrees. What is this green section going to be, that green inscribed angle? So if I drew another line, I guess I can do that real quick. Whoa, that is not... That's not a line. Where's the undo button? Oh no. Yeah, so we'll pretend like that didn't happen. All right, so I learned how to draw straight lines. I know you guys are going to be so proud of me. I hope this works. Yes, awesome. Look at that, perfectly straight line. I didn't cheat, I promise. Okay, so the inscribed angle here was 60. What's this inscribed angle? So this is still an inscribed angle. One of these is a secant line or chord. The other one is a tangent line because it only intersects in one point, right? But this is still an inscribed angle just like that one is and just like this one is up here. So if this was 60 degrees, I guess I'll go ahead and write that out. I wish I had my smart board, but that's okay. If this was 60 degrees, we know this one also is going to be 60 degrees. So altogether, these two angles would make 120. So what happens on the other side? Well, if I took this piece here and I extended it all the way out to that little reference point there, we have a proper tangent line going on the outside. And what do we know about the sum of these three angles? Well, if this is a tangent line, that's a straight angle, so they all have to add up to 180 degrees, which means this angle here is also 60. So let me go back to where we were before. In fact, I'll just draw another line. I think that'll be easier to see. Ooh, it did it again. Where's my undo button? quick undo. All right, there we go. I think it's because I lifted off the pen before I was ready. All right, so basically we took this section of 120, that's a 60 here. We took this section of 120, which is this 60 here, and then this section of 120, the arc, and the inscribed angle 60. And all three of those together add up to 180 degrees. So kind of cool stuff going on there. So when we're talking about inscribed angles, they, in this case, add up to 180, and the circle itself add up to 360 degrees for the measurement of their arcs. So that's why if we relate 360 to 180, oh, I'm on the wrong tool. Let's try that again. There we go. So if we do 360 and we divide that by 180, how are those two related to each other? What's their ratio or scale factor, if you want to think of it that way? That would be 2/1, or a ratio of 2:1. So the ratio of the central angle, the measurement of the arc, to the inscribed angle is going to be a ratio of 2:1. Pretty cool. All right, the only other thing I have to show you is inscribed quadrilaterals. So we did inscribed triangle, now inscribed quadrilateral, because these are kind of special. So an inscribed quadrilateral has got four sides, right? All four of the vertices are on the circle itself. They tell us 92 and 108, but we want to solve for A and for B. Well, there's a special thing that actually happens with this one, and I'll be honest, last year when I first saw these, I didn't figure out the easy way to do this, and I taught it very rigorously, and to prove this is kind of annoying also, until you see the elegant proof, and then that's what I'm going to show you today. So if the inscribed angle is 92 degrees, what do we know about the measurement of this arc? Well, it looks like a semicircle, but we don't actually know that. And in fact, I know it's not a semicircle because this is 92 degrees. So if that's 92 degrees, what's the measurement of this arc? Well, the inscribed angle is a ratio of 1 to 2 for the measurement of the arc. So if this is 92 degrees, that means that this arc has to be 2 times that, which is 184 degrees. So it's not actually a semicircle, meaning if I connected these 2 points, they would not go through the center point there. All right, so if that is 184 degrees, how could I solve for the measurement of B? So I'm going to draw the arc that's related to B, the inscribed angle B. And just from color coding this, you can probably very clearly see what's going on, right? So if this is 92, how is B going to be related to 92? Well, the better question, it's even more clear to ask, is how is 184 related to the blue arc? Well, you can probably clearly see that the sum of the blue arc and the red arc are going to be 360 degrees. So if this is 184, all we have to do is subtract it from 360 to find out what that value is going to be. So 360 minus 184, which leaves us with 176 degrees. So if this is 184, I wish there was a nice word like a supplement, but I don't really know of one. So anyway, the remaining part of 360 is going to be 176 degrees. So what then is the inscribed angle going to be? Well, if that's 176, to find this value, we just have to divide it by 2 because of the ratio is 1/2, right? So that's going to be 176 divided by 2. You can put that in as a fraction, but remember, a fraction is just division that hasn't happened yet. So if we did this as 176 and the numerator and denominator 2, we get the exact same answer. So just good stuff to know. All right, so we got 88, right? So the measurement of angle B is going to be 88 degrees. Let me see if I can write that in real quick. There we go. I'm getting better at this. All right, so that's going to be 88 degrees. So we got 92 and 88. Well, how is 92 and 88 related? Well, if these two angles add up to 100 or 360, then what do half of those angles add up to? Well, it's 180. So all we're doing is we know that the opposite angles here, the opposite angles of a quadrilateral, not talking parallelograms and stuff like that, we know those are congruent. But on any quadrilateral that's inscribed by a circle, the opposite angles are going to be congruent. And we could actually do the exact, or not congruent, sorry, they're going to be supplementary. We could do the exact same thing if we want, and I do want to, with the other two angles. So now we'll look at 100, let me move that one way out of the way. Oops, not trying to do that. Shh, don't tell anyone. They're all hiding down there the whole time. All right, so let's look at 108. So here we have 108 and its angle. So 108 is the inscribed angle. The arc's going to be on the top there. And if we double that, it's 216. Well, what do you know? And then we can look at the opposite one of the green one, which is the one on the bottom right here. Okay, cool. So how are the purple and the green related? Well, if that's 216, we know that if we subtract it from 180, we'll get 360, we'll get 144. And so those two add up to 360, so they're inscribed angles. The opposite angles of the quadrilateral that's inscribed is going to be supplementary. So 180 minus 108 is going to be 92. Or sorry, 72. Went the wrong direction on that one. Okay, so 72 degrees. And that's it. So inscribed quadrilateral is the opposite angle. So the opposite angles, so 92 and 88 are supplementary, and 108 and 72 are also supplementary. Kind of cool once you know the proof. All right, so an example, of difference between central angles and inscribed angles. So the measurement of arc AB, so the measurement of arc AB is going to be here. It's going to be the central angle. Well, we don't know what that is, but they told us the inscribed angle is 40. Well, if the inscribed angle is 40, we know that the central angle has to be 2 times that, which is going to be 80. So the measurement of the arc is 80. The central angle is also 80. So the measurement of angle B, which is measured by its central angle, is going to be 80 degrees. All right, this is Thales' theorem. I've shown this to you before. I showed it on GeoGebra. It's kind of cool, but I've got this nice graphic, so I want to show it to you. So if we have 180 degrees here, right, this is definitely a diameter. It goes through the center, and we have a semicircle with 180 degrees. So if the central angle is 180, then what do we know about the measurement of the inscribed angle? Well, if that is going to be 180 degrees, half of that is going to be 90 degrees, so this is going to have to be a right angle. Ooh, I could use that one tool. Might think about doing that. All right, so what if I went to a different point up here? And we did this actually when we were doing the Pythagorean theorem, or the converse of the Pythagorean theorem. So if I still have another inscribed angle, this time it's going to a different point on the circle, but it's still got a central angle of 180, so what do we know about this angle here? Well, just like this one, it's also a right triangle. And this is where Thales comes in. Okay, so we can do the same thing with the yellow one, which you can actually see, which is kind of cool. And we could do it with the other colors, the cool colors, the warm colors of the color wheel, I suppose. Any point here, any vertex that we choose on the circle and go through 2 endpoints of a diameter will give us a right triangle. So Thales' theorem states that all the possible lengths, leg lengths of a right triangle are found that have a certain hypotenuse of this diameter are found in the semicircle of the circle with that diameter, which is actually pretty cool. All right, so we're on the homework now. Again, I'm just going to assume that you've print these off. So if you look at Google Classroom, you'll have the assignments there. They're PDFs, so you can get a PDF editor. You can annotate them if you're using a tablet, or you can print them off, which most of you will probably want to do. So let's look at number 1. So this is 136 degrees. That's going to be the measurement of this arc here. So the measurement of the inscribed angle A is going to be half of that. So if you're not sure what that is, we can just put it in the calculator. So that's going to be 136 divided by 2, which is 68 degrees. So this would be, let me try that again, is 68 degrees. So you can mark that off on your answer bank. So if you look over on the right there, I didn't put it up on the screen, but you get it. Just kind of grade your assignment as you go because I won't be able to grade them for you. All right, number 4, we have the angle up here, which is going to be the arc of 42 degrees. So the inscribed angle is going to be half of that, which is 21. B is the inscribed angle for 84, so half of that is going to be 42. It's nice when we have these nice and even numbers. So the only other question we have left is, what is the measurement for angle C? Let me change colors real quick. Well, angle C is going to be vertical with this angle here. So how are we going to find out with these two? We know they're congruent, but what do we know about those two right angles? All right, you're probably screaming at your phone again or screen or whatever, and I can hear you, I promise, so don't stop screaming. We know that this is a triangle, right? So all 3 of these angles have to add up to 180. So when we add those 2 together, we can subtract that from 180. So that's 63. We subtract that from 180. So let me go over here. So we have 180 minus 63, which is 117 degrees. So the measurement of angle C is going to be 117 degrees, just like this one in here is also 117 degrees. All right, number 7. This is an inscribed quadrilateral. So you remember what our trick is? What do we know about those opposite angles of an inscribed quadrilateral? Well, the opposite angles are going to be supplementary. That's because they cut the entire circle into 2 parts, where we have one arc opposite of 87, which is going to be 2 times 87, and then the arc opposite of A, which is going to be 2A, and we know those 2 all together have to add up to 360. So what is the supplement of 187? So put that in your calculator if you're not sure. So we do 180 minus 87, which is going to give us 93. So angle A has to be 93 degrees. Now, I'm pretty sure I made it where there are other ways to solve this problem using this angle 36 here. But, you know, let's use our shortcut. That'll be helpful on the test too. So then we have 78 degrees here. We have 93, 78, and then 87. Well, we can find the missing inscribed angle here by using what we know about quadrilaterals, which is that they add up to 360. So you can add all those together if you'd like and subtract them from 360. So I'm going to do 78 plus 87 plus 93. Okay, and then I'm going to subtract that from 360. So 360 minus 258, which will leave us with 102 degrees. So this missing angle here would be 102. Do we actually even need that one? No, my bad. All right, so we know if this is 78, then 2 times that's going to be 156. So we have 156 minus 36, which is going to be 120. That's going to be the measurement of arc B. And then if that's 93, we know that the bottom part here is going to be 186. Minus 36 is going to be 150. So that's how you can find the missing arcs. Sorry we did a little extra work there. Look at number 10. So on number 10, I color code these so it's pretty obvious. But if this is 56 degrees, that's this arc. We know the inscribed angle is going to be half of that. So half of 56 is going to be 28 degrees. So that's 28 degrees. The next part, let's see. Okay, so if the measurement of this arc here is 112, that means the central angle is also 112. And then what do we know about these 2 lines? So let me change to my tool. There we go. So what do we know about these 2 lines? And I'll change colors. This line here, this segment, and this segment right here. What's special about those 2? Again, I can hear you screaming. Those 2 are radiuses. And what do we know about radiuses? They're congruent, which means this whole triangle here is a special kind of triangle. It's an isosceles triangle, meaning the sides are congruent. So we know the base angles are also congruent. So if this is A, see if I can just duplicate that. Yeah, showing all my tricks now. All right, so if that is A, we know this side over here has to be A as well. So let's subtract 112 from 180 and then divide it by 2. So when we do that, we do 180 minus 112, and we divide that by 2, which will leave us with 34. So the measurement of angle A is going to be 34 degrees for both of these. Try that again. Okay, yeah, I guess I have to click on it first. So A is going to be 34 degrees. All right, the only thing we have to solve for now is C. So if you look, C is the angle that is formed between this chord and this tangent over here. This is a tangent because it only intersects in one point. So it's the same inscribed angle as if it was both of them were on the circle, because it's still on the circle, it's just a tangent line. So what we want to do is we want to find out, let me change colors real quick. We want to find out what is the length. Ooh. That's so rough. Anyway, now you can appreciate the animations I do. What is the length of this arc here? Well, if this is 56, it's a semicircle as well because it goes through the center. That's going to be a supplement of 56, which is going to be 100 and I guess I'll just put it in. So 180 minus 56, which is equal to 124. So this arc here is going to be 124. So the inscribed angle is going to be half of that, which is 62 degrees. So there we go. All right, 15, I'll get you started on this one, but I'll let you finish it. There's a lot going on in that diagram. First thing we see is that this angle up here, they tell us, is going to be 20 degrees. So if that's 20 degrees, then what is the measurement of arc AB? Well, AB down here is going to be the measurement of the arc from the inscribed angle. Well, if the inscribed angle is 20, we know the central angle is twice that, which is 40. So the measurement of the arc is also going to be 40 degrees. Now for DC, if we notice these two markings here and here tell us those angles are congruent. So if this is 40, they're telling us this is also 40. So then DC would have to be 40 as well. What about angle E? Well, we guess we can define E there because you can kind of figure out what angle we're talking about, but that's not very well defined. We should say the measurement of angle AEB. So we're talking about this angle right here. So to find the measurement of that angle, just look off this. So that angle is going to the arc 40 degrees. So inscribed angle from 40 is half of that, which is 20. Notice it's the exact same half as this one over here because they're both inscribed angles going off the same arc 40 degrees. So that would be 20. And then what about DFB? So DFB. Okay, so that's going to be this angle right here, including the 40. Well, you're probably tempted to say that this is 90 degrees, but check again. We know this is going to be a diameter, so it adds up to 180. 40 and 40 is 80, so the missing part in the middle is actually 100. So we have 140, which is going to give us 140. So DFB is going to be 140. All right, 16, this is an inscribed pentagon, a regular pentagon. So it's got 5 sides, so 5 central angles if we extended all of those. So you can find each one of those by doing 360 divided by 5, which again, you probably have this memorized from our polygon unit, is 72 degrees. All right, so that's 72 degrees. The central angle is 72. That means the opposite angle here, not the opposite angle, but the measurement of the arc is also 72. So the inscribed angle is going to be half of that, which is 36 degrees. So pretty simple. Working on my penmanship. Okay, that's it. So finish your assignment, and I'll upload tomorrow's assignment. Shouldn't take me as long because now I got my computer going. It doesn't take an hour and a half to render a video. I think it'll do in 5 minutes. I'm so excited. Yeah, so tomorrow you're going to want to tune in. We're going to be talking about tangent lines, and that's the NASA math one. So pretty excited about teaching you guys about some NASA math. It actually has some really practical real-life applications. You'll never go to the beach the same. That sounds weird saying that in these times, but you'll never see like lifeguard towers and lighthouses and think of the same thing anymore. So I'm going to kind of ruin the beach for you. You're welcome. So stay tuned for tomorrow. If you want to subscribe to the YouTube channel, all the videos will post there. You can just watch it there, and then go to Google Classroom to find the actual assignments themselves. So I will see you guys tomorrow.